Okay, so in this video I'd like to discuss how we're going to approach the diffuse component of our shader. And for the diffuse component we need to simulate light from our environment, from our HDRI image, entering our CG scene and scattering off of diffuse surfaces. If we recall, when light hits a diffuse surface, it scatters in all different directions. So now we have this complicated light source, our HDRI, that is going to be sending light into our scene, and that needs to scatter off of diffuse surfaces. And the calculations for doing a diffuse lighting when using image-based lighting are actually fairly complicated. I mean, we can think about just a single point light, a single CG point light, and how that illuminates a diffuse surface, and we know that we get a broad area illuminated due to the light scattering properties of that surface. Well, that's with a single point light. Imagine now that we've got this entire environment of light, which means that light from different portions of the environment are going to be hitting our surface, they're going to be scattering, and that means that we're going to have different proportions of light coming from different areas in our environment. It's a very complicated set of calculations, and if we had to calculate these at render time, it would just be so inefficient, because not only are they complicated to calculate, but we'd be calculating them over and over and over again for all of the images that we're rendering in our rendered sequence and for different portions on different objects that we're rendering in a single frame. So we really don't want to be calculating these at render time. So instead, what we're going to have to do, we're going to have to pre-process the HDRI image. And we can do that just the once. It's an offline calculation, if you will. It doesn't occur at render time, it occurs before render time. And the results of this pre-processing can then be used very quickly when rendering. To do this, you can use a program such as HDRI Shop, and that can take in the original HDRI panorama that we had. So it can take in an image like this, and it can process it by applying a diffuse convolution algorithm to the entire image, and the end result is something that looks like this, which may just appear to be a blurry image, but in actuality this is a result of a very complicated algorithm being applied to our HDRI. So the end result is also an HDRI, but it's an HDRI that has some special properties, because it's now simplified the diffuse lighting process for us, whereas before we'd have had to have worked out all of the light information coming from various different portions of our environment scattering on our surface, and the result of that giving us the illumination, if you will, the diffuse illumination of a specific point on the surface. It's now been simplified down into a normal based lookup. And so what do I mean by a normal based lookup? Well, let's bring up a new layer. There we go. Grab our brush. So we can imagine that we're rendering a surface in our scene, and there's a particular point on that surface that we want to render. Well, we're going to determine the surface normal n of that point that we're rendering. And now, whereas before with this surface normal we'd have had to have determined all of the light from different portions of our environment all coming in and scattering on our surface, and all of that lighting information combines to give us the light that is truly illuminating that single point. As I undo, there we go. Now all we need to do is use that normal as a lookup into our newly generated diffuse convolution, because we can imagine, if you will, that we have our environment, and our environment is really just a big sphere. There's a big image that can be applied to a sphere that sits around our object, and with that normal, that's going to point to a specific point on that environment, and the specific point on that environment has a specific latitude, longitude, and we know with a specific latitude, longitude that we can use that to look up into our 2D image a specific pixel value. So now on the processed diffuse convolution image, the pixel value that our normal looks up based on the latitude longitude value, this pixel value represents the lighting information that is reaching this particular point. We don't have to go and apply a whole load of diffuse lighting calculations. That's been done for us. We simply have to grab the color value, the intensity value of that pixel, and that tells us the diffuse lighting that is reaching the basically a point on a surface that has that surface normal direction. Now, the problem, however, is that even calculating the image offline, all the diffuse calculations offline, the diffuse convolution is still computationally expensive. It still takes a long time to calculate. Therefore, if we were to perform it on our full resolution HDRI, which for my project, the full resolution HDRI was many thousands of pixels wide and thousands of pixels tall, would have just taken forever. We can't use the full resolution and try and calculate these diffuse calculations. It would just take forever. However, we can perform it on a low-res version of the HDRI. So I actually resized the HDRI down to 256 pixels wide and 128 high, then applied the diffuse convolution calculations to that, and that gave us this resulting image. Now that may seem very small. I mean, 256 by 128 doesn't seem like many pixels, but since this image is heavily blurred, it actually doesn't matter. The fact that it's a low resolution, you'd be surprised that you can actually still use this for diffuse lighting, and for, at least for renders at power resolution, 720 by 576, you can't actually notice the fact that it's such a low resolution image. In fact, you'd be surprised how low even the reflection images can get. Even the most crisp reflection map on my project was only 256 by 128. All of the images, all of the processing on the HDRI was performed on an image that was 256 by 128, and with that information, with complicated surfaces, with texture maps all involved, and with the fact that no one surface was ever really close, really big to the camera, the fact that it's 256 by 128 really didn't cause a problem. And by calculating it on a 256 by 128 pixel image, it meant that those convolution calculations took place in a matter of 4 or 5 minutes per image, as opposed to days and days and days per image. So the end result of the calculations in this case, since we are interested in diffuse lighting, is our diffuse convolution. It's our image that appears to just be a blurry image, but it really gives us a normal base lookup of diffuse lighting. And we can take this, and to use it in Houdini is actually really simple for implementing diffuse lighting, because we can apply this as a map to an environment light, and then we can apply a simple Lambert shader to our object, and that will give us the diffuse lighting that we require for our scene. However, we'll see when we implement this in the next video that that actually only gives us a single render pass back. It gives us all of the lighting information, the shadowing information, and the color of the surface, if you will. It gives us that as a single render pass, and it also means that we have to deal with both a shader and an environment light in our scene. Now, there are ways to work around the render pass, but also the fact that we have to deal with an environment light and a shader in our scene, and they're two distinct objects, that, or rather two distinct entities, that is a rather bigger issue. So we're also going to take a look, after we implement using the environment light, we're also going to take a look at how we can use multiple different passes within our shader to achieve the same end result. It's going to give us the same visual end result. It will still give us diffuse lighting, but it gives us multiple passes that we can use to tweak the various aspects of our lighting, and it also means that it's contained within a single shader. And the benefits of this will be discussed as we approach it, but it's just so that you guys have an idea of, we are going to be approaching this using an environment light, but we are then going to turn around and re-implement it in a different manner. So that's the direction we're going to be going in over the next series of videos. But for that is going to wrap up this video. Thanks a lot, everyone.